Good morning, all of you. My name is Tamosa Chakraborty. I am an assistant professor of Haldia Institute of Technology. Today, we are going to start a new topic, that is Introduction to Theory of Computation. Now, when we had the term that theory of computation, the first question comes to our mind: what is computation? Now, computation is something that needs to be computed to get a desired result. Now, how can we get the desired result? First, we have some problem statement, that is our inputs. Now, we have some methodology, that is computation methodology, and next we will get some result, that is our output. So, this is my computation. So, we have some inputs, we have some computational methods, that inputs mixed with that computational method to get a desired result or output. That is my computation. Now, when we discussed about computation, three questions come to our minds. The first one is what to compute. Second one is how to compute. And the third one is how efficiently we can compute. Now, these all questions will be answered by the subject theory of computation. Now, theory of computation will consist of three different topics. First one is computability theory, second one is automata theory, and third one is complexity theory. Now, computability theory deals with what kind of problems are computable. That is my computability theory. Now, next is automata theory. Now, automata theory is something which deals with the mathematical model which can perform the computation. And third one is complexity theory. Complexity theory deals with the efficiency of these machines or mathematical models. Now, first we will discuss computability theory. Computability theory consists of two problems. One is computable and another one is not computable. However, whether a problem is computable or not, it will be decided by a term that is called algorithm. Now, what is an algorithm? Algorithm is nothing but a procedure to solve a problem if that procedure produces a correct output for every possible input. That will be called as algorithm. Am I clear? Okay, I am saying it again. Now, if a process or method produced a correct output for each and every time, then the process is called algorithm. Like, say suppose we know 2 plus 2 is 4, equal to 4. Now, what is my what I am doing? I am doing an addition, right? Now, we can say that if every time my addition method will give me a correct output, then it is an algorithm. That is, when I am doing 2 plus 2 is equal to 4, okay, fine, that is correct. Now, if I am doing 3 plus 2, if I get 3 plus 2 is equal to 4, that means that same plus sign is giving me wrong output. That is not an algorithm. If that summation or addition is giving me correct output for each and every time, correct, then it will be called as an algorithm. Okay. Now, a problem is computable if there exists an algorithm. Okay. So, the problem is computable if we have an algorithm to solve that particular problem. Then only it will be called as an algorithm. Okay. Otherwise, it will be a non-computable problem. That is, if no such algorithm exists, the problem is non-computable. Next topic is automata theory. First of all, the term automata is derived from a Greek word automata, which means self-acting. Okay. Now, in our subject, the term automaton refers to an abstract self-acting computing device that autonomously execute a predetermined sequence of operations. That means automata or automaton is a self-acting computing device which follows predetermined sequence of operations automatically. Now, what does it mean by predetermined sequence of operation? That predetermined sequence of operation is our algorithms. We have some steps in the algorithm. We have some steps and we have to solve a problem according to that steps or that sequence of operations. Correct? So, that predetermined sequence of operations is our algorithm. So, that means an automaton is an abstract self-computing device that follows an algorithm automatically. That's why it is known as automata. That is self-acting. Now, automata theory broadly consists of 4 topics. One is finite state machines or finite automata. Second is push down automata. Third is linear bound automata. And the fourth one is Turing machine. Okay. Now we comes to complexity theory. Complexity theory deals with how efficiently the problem can be solved by the machines or mathematical models. Okay. Now, complexity theory is also deals with the term efficiently. How efficient my machine is. Is it efficient enough to produce the desired output all and each and every time, or it has some drawbacks? So, your efficiency will be dealt by the complexity theory. Okay. Now, there are 2 major aspects of complexity theory. The first one is time complexity and the second one is space complexity. Now, time complexity is something which determines how many steps does it take to perform the computation. Okay, that means I have a problem statement. I have a predetermined sequence of operations, that is my algorithm. Now, how many steps or how many iterations I need to perform for to solve a particular problem is my time complexity. Okay. Now, space complexity is dealt with the memory. Okay, where to save the computational problem or where to save the algorithm. It's all about memory. So the space complexity is dealt by the memory. So how much memory is required to perform the particular computation is known as space complexity. So in the introduction to theory of computation, we have done we have discussed what is computation, that is we have some inputs, we have some computational method, and when the input mixed with the computation method, they will give us a desired output, and that method is computation, correct? Then we need to know that the theory of computation is all summation of three other topics, three other theories, that is computability theory, automata theory, and complexity theory. Now computability theory is all about what kind of problem is computable or not computable. Automata theory deals with the mathematical model which can perform your computation, and complexity theory deals with efficiency of the machines or mathematical model. Then we comes to know that computability theory is all about computable. A problem is whether computable or not. When it is computable, if a problem have a particular algorithm, then the problem is computable. Otherwise, the problem is non-computable. Automata theory deals with the it is a self-acting device or computing device which follows an algorithm automatically. It has 4 categorization. That is finite state machine or finite automata, push down automata, linear bounded automata, and Turing machine. One more thing, in automata theory, after this slide we will discuss the introduction to automata theory. In automata theory is all about your language, your symbols, your alphabets, grammar. You may ask me that it is not a we are having a computer science paper, then how language, grammar, it is a part of your English. Okay, so it is kind of similar thing, that how automata theory deals with that grammar, language, symbols, all this. And then we have complexity theory, that is how efficiently the problem can be solved by the machine or mathematical models. And in complexity theory we have 2 major aspects, that is time complexity and space complexity. Now time complexity is all about how many steps it will take to perform a computation is your time complexity, and how much memory is required to perform the computation is your space complexity. So thank you. It's all about introduction to theory of computation. Thank you.